Welcome to Foundations of Computer Networks. This is session 12, and we want to look at a subnetting example. So here we have our IP address. And by looking at the IP address, we know that it's a Class C IP address. It begins with 192, and it also falls into the Class C private address range because it says 192.168. And if we just go back to our previous slide, we know that it's a Class C address because it falls within this range, 192 to 223. And we also know that it is going to be the private IP address because it falls within this range, 192.168. A Class C IP address, by default, has a CIDR value of /24. And we know this because for the last octet of the subnet mask is going to be 0. So the subnet mask is going to be 255.255.255.0. And what this tells us is that the last octet, the one with the 0, all the bits are going to be turned off. If all the bits are turned off, then it therefore means that all of these bits are associated to the host. So therefore, in order to know the total number of IP addresses that we are playing with, it's actually going to be equal to 2 to the 8. So it's going to be equal to 2 to the 8. Which we know gives us 256 different patterns. In other words, there are 256 IP addresses which are present in this range that we are looking at. The question, however, says that we need to create 4 subnets. In other words, we need to divide these 256 IP addresses into 4 rooms or 4 distinct divisions, because that's what a subnet is. So we want to create 4 subnets. So the question is, how many of the 8 bits which are associated with the host that we need to use as our subnet? And if we look at that, we want to create 4 subnets. So the question is, to create 4 subnets, how many bits do we need? Well, we need 2 to the 2 bits, which means that we need 2 bits because we're looking at the exponent. So we need 2 bits to be able to create 4 subnets. It therefore means that we are going to end up with something that looks like this. So SS, HH, HH, HH. So the first 2 bits are going to be our subnet bits because we want to create 4 subnets and we need to borrow 2 of those bits and use them as if they were network bits. And if we use 2 out of the 8, then it means that 6 is going to be left. So therefore we know that S is equal to 2, and we also know that H is equal to 6. And if we use that, then what we end up with, 2 to the 2 giving us 4 subnets. So that's 4 subnets. And how many hosts do we have within each subnet? Well, that's going to be 2 to the 6. And if we look at 2 to the 6, then we are going to see that we end up with 64 hosts. A better term here would be that we end up with 64 IP addresses. So let me just put that inside bracket. And the reason why we want to be specific in terms of the fact that it's 64 IP addresses is because 2 IP address out of the range is reserved for special use. We have spoken about that before. The first one is going to be the network ID, and the last one within the range is going to be the broadcast ID. So we need to account for that in our calculations. Another thing that becomes important is because we have borrowed 2 bits to be used as network bits, or we have 2 bits as our subnet bits, then it means that the CIDR notation is going to change. So the CIDR notation is going to now move up by 2 bits. So it's 24, which is the original Class C CIDR notation, plus 2 subnet bits. So we're going to end up with a /26. And if we change the CIDR notation, then it means that the subnet mask is now going to change, because the last octet can no longer be 0, and we need to determine what is it going to be. So there are 2 subnet bits which are used, which were borrowed. So therefore, if we go to our table, we know that the first 2 bits are being turned on in the subnet. So if we add up these 2 values, then we end up with this value here, 192. So therefore it means that this new subnet mask is going to be 255.255.255.192. So just to make this clear, if we see 255.255.255.192 as our subnet mask, then what that tells us is that we are now using the concept of subnetting to divide the IP address range into subnets. And in order to figure out how many bits we are using to represent the subnet, then we can simply convert it to the CIDR notation, because 192 means that we have borrowed 2 bits out of the host to be using as subnet bits, and therefore when we add that 2 bits to the natural Class C CIDR range of 24, then we end up with a new CIDR range of 26. Let's now quickly compute the IP address range and have out where it starts, where it ends. So what we know is that the first IP address is going to begin at, so I need a bit more space. Let me Alright, good. So let's now write out those IP addresses. So the first one is going to be 192.168.100.0. That's where we start. And we know that the number of IP addresses associated with each subnet is going to be 64. So therefore it means that the next one is going to be 192.168.100.64. And then we know that the next one is going to be 192.168.100, and we are going to add 64 to 64, and that gives us that 128. And we know that we should have 4 subnets, so we are going to go one more time. So it's 192.168.100 dot, and then we add 64 to 128. And when we add 64 to 128, we end up with 192. So it means that this last octet is going to be 192. So what we have there are the starting ranges for each of the subnets. In other words, these are going to be the network IDs for each subnet. Now, where does this end? It's going to end before 64 is reached. So it means that this is going to be 192. Alright, let me get the formatting over on this side. Let me use it here. So it's going to be 192.168. We're trying to find out where it ends, where each range ends. So this is going to be 100.63 because it must end before we reach the other subnet. And this other subnet is going to be 192.168.100, and it must end before we reach the subnet below. So it means this one ends at 127. And then for this one, it's going to be 192.168, and I'm sure that you see the pattern now. Dot 100.191. And then this one is going to end at 192.168.100. And I'm sure that you guess it. It's going to be 255. So we have our starting addresses for each subnet, or these are going to be the network IDs for each subnet. And we also have the broadcast address for each of these subnets, which are going to be the endings. And let me just put all of this in a different color so that you are a bit clearer in terms of the visuals. So the blue are going to be the network IDs, and the purple are going to be the broadcast IDs. So that's what we have. So we have created the 4 subnets. We have indicated the IP ranges for each subnet. We know that 2 IP addresses out of each subnet is reserved for special use. First one being the network ID, the last one being the broadcast ID. And then the final question now becomes, how many usable hosts do we have? And because we have 64 IP addresses being used in each segment, and we know that 2 of them are reserved for special use, then that means that we end up with 64 minus 2, which gives us 62 usable IP addresses. And what this tells us is that within each of these subnets, we can have up to a maximum of 62 devices which are operating or communicating on that network, because each of them can be assigned a unique IP address out of the 62 usable IP addresses. I hope this serves to illustrate how we actually go about creating the subnets, and hope it also illustrates how we convert between CIDR notation and subnet mask and all the other things that are attendant when it comes to dealing with a Class C IP address. Now, a Class B and a Class A IP address is going to be similar in concept. However, we treat it slightly differently because we now have a wider range of IP addresses that we are going to be working with at each of these stages. So in our next example, we will illustrate how this can be done. Take care.